Hi class, this is part 2 of my moving on the sample test 1 on chapter 3, and I'll be doing question number 13. In this example, they say, suppose that r of x is a polynomial of degree 7 whose coefficients are real numbers. Also, suppose that r of x has real zeros, I and -4 minus 4i. It turns out when we have complex zeros, they come in pairs, which are the conjugates. So the conjugate for I would be minus I, and the conjugate for -4 minus 4i would be -4 plus 4i. So the conjugate just changes the sign of the imaginary part of the complex number. So it's asked us to find another zero. So as long as we pick either the opposite of I or -4 plus 4i, Alex will say we're good to go. So I'll select the box. I'll type in -4 plus 4i. I can use the keyboard to type in I, or I can use the equation editor to type in I. So either one of those ways to type it in. So if you plug in -4 plus 4i, or if you plugged in I, Alex would say you're right. The next question says, what's the maximum number of real zeros that r of x can have? So since we have a polynomial of degree 7, we know that we have 7 possible zeros. So I'll start with 7. Then if we take away 2 for the first, that will leave us with 5. So that's removing I and minus I. And then if we take away another 2, that will leave us with 3. So we could have 3 real zeros. The next question says, what's the maximum number of non-real zeros that we can have? And what I'm going to do is I'm going to go out and to Excel just to show you how I capture this visually. You wouldn't need Excel. All you would do is draw boxes on your piece of paper for the 7 zeros. So let me open up Excel so you can see what that would look like. So now I have Excel open, representing my 7 zeros. So I need to reduce some here because I have more than 7. So let's take away these 2. And then let's change the formatting of this box as well. All right, so now I have 1, 2, 3, 4, 5, 6, 7. So 7 boxes is what you would draw on your paper. And then I would remove my complex numbers. They come in pairs. So I'll use the highlighting tool to do that. Oops, let me make sure I click in the place where I want to have the highlighting tool. So let's put it here. So I'm going to highlight my pairs here. This one's going to also. So that represents I and minus I. And then I'm going to have the same thing for -4 minus 4i and -4 plus 4i. So this is I and minus I, -4 minus 4i, -4i plus 4i. So there's my 2 complex pairs. I could have another complex pair because remember they come in 2s. So I could go one more. But I couldn't go another pair because that would give me 8 possible zeros. And remember the degree is 7. So I can see that I could have 1, 2, 3, 4, 5, 6. So just know that your complex roots or your non-real zeros are always going to be an even number because they come in pairs. So let's submit our answer. It says you only did one question, I know. But we got it right, so we must have been great. So let's do a quick retake. Oh, you know what? A retake, though, is probably only going to let me. Oh, no, it lets me do them all. So let's do another version of 13. All right, perfect. So it says find another zero of r of x. So since this one has a complex root, I'm going to take that one. That's the easier one. So I'm going to find the conjugate of -3 minus 4i. So that'll be -3 plus 4i. And then it says, what's the maximum number of real zeros that it can have? Well, it's degree 8. And if you take away the complex pair, that will leave me with 6. And then if I have 6, and then if I take away 5, the first root of -4, and then the next one of 5 and 8, that'll take away 3 more roots, so that'll leave me with 3. And so that would say I would have 3 possible zeros. That would be real. Now, there could be a pair of complex in there. All right, so then I'll go out and draw my boxes again. So now I have my 8 boxes representing the degree 8 polynomial. And then I'm going to put in my complex pair. So that's one complex pair. Then I could have another. Oh, I got to subtract out the 3 real roots. Let me get rid of the 3 real roots. So let's make the real roots yellow. So one there, another one there, another one there. I should have started with that. So then if I had those 3 real roots, then I could see that I could only have 1, 2, 3, 4. I can't have another one because remember the complex numbers come in pairs. So the most that I could have is 1, 2, 3, 4 complex roots. Oh, we got 7%. Oh, I messed up somewhere. Let's take a look at my report. Oh, I forgot this. I said that we could have 3 more, but what's 3 plus 3? This should have been 6. Sorry, we had 3 possibilities, and then the other 3 that we have would make 6. Sorry, my error. So it should have been 6. Yeah. All right, let's do it one more time so I can end on a more positive note. All right, yeah, this is better. Okay, perfect. All right, so here it says find another complex 0, so I'm going to do -4 minus 5i. And again, if you click any of those conjugates, it will work. So if you do -4 minus 5i, positive 4i, 1 minus I, any of those values will work. So then it asks for the maximum number of real zeros, and this is a degree 9. So if it's of degree 9, and we have 1, 2, 3 complex numbers, they come in pairs, so there'll be 6. So if you do 9 minus 6, that'll leave you with 3 left. If there were some real numbers that had also given to us, it's still 3, and those would be included in the lot. All right. So let's go ahead and take a look at the next one. What's the maximum number of non-real zeros we can have? Well, we already have 9. So if you have 9 boxes, that means you're going to have 2, 4, 6, 8 rows and 1 left over. So that means the most that you could have is 8. The 6 that you have plus another pair would make 8. You can't do another pair because that would make 10, and we only have 9 possible roots. So I hope this movie on part 3 is helpful.